Okay, so we're still dealing with compositions of trig functions, but there's a little bit more going on, and what we just have to do is be aware of the identity that's being shown. So like in this first one, we have sine of 1/2 times the cosine of the inverse cosine of negative square root of 3 over 2. Now again, remember, this part right here just represents an angle. So we're talking about theta being the inverse cosine of negative square root of 3 over 2. So essentially what we're doing here is we're looking at the sine of 1/2 of theta, which is basically the sine, right, of theta over 2. So that's the first thing we have to figure out, that this is actually that. And so what this becomes, if we go back, and by the way, the trig identities, the double angles, the half angles, the sums and all that, those will be given to you. So I don't mind you guys having a little cheat sheet out with those on when you're taking quizzes. For those who will eventually take the final, you'll have those same things. So reach out for one. So what do we know about the sine of a half angle? Well, when I reach back and we look, it's plus or minus, right, the square root of 1 minus the cosine of theta all over 2. So we basically have to figure out that. Well, here's what's nice, right? Because if we come over here, right, we know that the cosine of theta is negative square root of 3 over 2. And so that is all I need to finish this problem off, right? So there's really not any, we don't even have to go back to any restrictions. When I rewrite the half angle for sine, all it needs is the value of cosine. And since we were given that the angle of the inverse cosine is this, that essentially means that the cosine of that angle, whatever that angle is equal to the negative square root of 3 over 2, which I think we know that's 150 degrees, but I actually don't need it here. So we got plus or minus, and we're looking at 1 minus the square root of 3 over 2, right? It's a negative all over 2. So let me write that a little bigger. We have 1 plus the square root of 3 over 2 all over 2, and now it's just a process of cleaning all that up. And again, what I like to do is, since this is a compound fraction, I'll multiply both top and bottom by 2 to basically clear those fractions out. So we're looking at plus or minus, we have 2 plus the square root of 3 all over 4. And so if we break this up, this is plus or minus 2 plus the square root of 3 all over the square root of 4. And so what I'm finally getting, I'm kind of going around in a circle here, sorry, because I got to make room for this guy. It looks like we have plus or minus the square root of 2 plus the square root of 3 all over 2 in the end. And then now we have to figure out, is this plus or is it minus? Well, we know this is 150 degrees, right? So let's just kind of go ahead and use that. So if I take half of that, we're talking about 75 degrees, which puts us in quad number 1. So we have the positive. So using all that stuff together, we're talking about the square root of 2 plus the square root of 3 all over 2 as our exact answer for part A there. So a lot going on there. We're using a lot of our trig, a lot of our algebra to finally figure that out and get a process going. So in the next one, right, a little tougher, again, we have to remember that theta in this case is the arctangent of 12 over 5. Okay, so this basically means that the tangent of theta is 12 over 5, and we'll come back to that in a moment. So what we're really looking at here is the cosine of 2 theta, all right, if we replace the arctangent. So what do we know about the arccosine of 2 theta? Well, we actually have 3 different ways to write that function. I'm going to write it in terms of its cosine. So we know that this is 2 cosine squared theta minus 1 when we invoke one of our double angles. So if I can find the cosine of theta, I can pretty much find the value of this crazy guy here. So let's go back over here and find the cosine of theta. So we know that the tangent of theta is 12 over 5. This is y and this is x. Since we're talking about the arc cotangent, we know we're in quad number 1, or rotated positively, or we're in quadrant number 4, rotated negatively. But since this is positive, that means we're basically in quad 1. So that tells me my x is 5, my y is 12, and we basically need to find our r. So 5 squared plus 12 squared is equal to r squared. That's 25 plus 144 equals r squared. R squared is 169. Taking a square root, we get 13 out of that. So my cosine for this situation is the x value over the r value. So we can now come back over here and we're looking at 5 over 13 squared minus 1. And then it's just a process of doing some fraction work. So this is 2 over 1. This is 25. We know that 13 squared is 169 minus 1. So this is 50, 169 minus 1. So this is 50 over 169 minus 169 over 169. And I think we get a negative 119 all over 169. So there's what the value of the cosine of 2 arctangent 2 over 5 is. So again, a lot of stuff that we've done previously. First, recognizing it for the double angle that it was. You know, we could have used sine if you wanted to, and we could have done all this analysis and found sine, but I chose cosine. Come back over here and use what we've been learning about the arctangent. That tells me what quadrant am I in, gives me the ability to find my r, which gives me the ability to find the cosine, and then eventually come back over here and find that exact value. So a really good problem. It's almost a great review problem because it's using the new stuff in combination with the chapter 5 stuff, in combination of things we did way back when in chapter 2? Chapter 1 when we were talking about XYR definitions. Last but not least, we have the cosine of the inverse sine of 3/5 and the inverse cosine. So again, we have to remember these guys represent angles. So let's say theta is the sine inverse of 3/5, and let's say that beta is the cosine inverse of 5/13. So we're basically rewriting this. We're talking about the cosine of theta plus beta. And we know this to be the cosine of theta, right? For the sum is cosine of theta, cosine of beta, right? Minus the sine of theta, sine of beta. So that's pretty much what we have to find to finish this problem off. Now coming back to what we know about theta, this is telling us the sine of theta is 3/5, and this one is telling us that the cosine of beta is 5/13. So that's pretty good to know because we now know, right, this is 5 over 13 and minus this is 3 over 5. So this kind of takes us back to the previous chapter where we just now need to find the cosine theta based off of what we know, and we have to find the sine beta of what we know. And by the way, in terms of quadrants that we're in, since sine's positive and we're invoking the inverse sine, we know we're in quad 1. Same thing here, since we're invoking the arc cosine, we know we're in quad 1. So everything's in quad 1 based off of the restrictions we have for the inverse sine and inverse cosine. And again, how do I find the cosine of theta or the sine of beta based off of what I know? Lots of choices. We can use XYR definitions, we can use right triangles, we can use trig identities, whatever you want to do to get the job done. So how about I use a trig identity for this one since we used XYR definitions here. So this basically tells us that the cosine squared theta, right, is plus 3/5 squared is equal to 1. This says that the cosine squared theta is 1 over 9/25. So this is 25 over 25. So cosine squared theta is 16 over 25. Invoking my square root, we get that cosine theta is plus or minus 4 over 5. But since we know we're in quad 1, I know my cosine of theta is 4/5. So we now have that value to basically work with. So we've used XYR definitions up here. I use trig definitions here, trig identities. How about I use a right triangle here? So we're in quad 1. My quad 1, my cosine has a 5 and a 13. So we just basically need to find that y value. So using my Pythagorean identity, we know that 5 squared plus y squared equals 13 squared. So y squared is 169 minus 25. Y squared is 144. Take a square root. Y is plus or minus 12. We're in quad 1, so y is 12. So what is my sine of beta? Well, it's my y value over my r value, which is 13. So we get 12 over 13 there. And now we're ready to just do some math. So we get 20, I believe that's over 65, minus 3 times 12 is 36 over 65. And we get a negative 16, over 65. Let me write that a little nicer. Negative 16 over 65. So here we had basically our cosine of a sum, right? And we know how to break down a cosine of a sum, and then it was just a process of using our inverse functions to find some information that we needed with regard to sine of theta and cosine of beta given what we had. So we're kind of going back in time and redoing a bunch of stuff. Again, we're using a trig identity, we're finding an exact value based off of information that we know, and then of course to nail down the quadrant we're in, right, we're using the inverse functions to help us nail down the quadrant so I know how to draw my pictures and know what, if we're positive or negative, or whether, my x's and y's are positive or negative respectively. Okay, so there you guys have it. Those are about as hard as they can get because we're putting, again, a lot of our course together all in one problem. So it's a very, very good review. Alrighty, so we got, I think, a couple more ideas to wrap up, and then we will finally be done with section 6.1. See you guys in a moment.